चलो ठीक है, कोई ये नोट भी कर ले. दिस इज समर 1912. ठीक है, we're going to try and solve this paper. First thing apparatus के ऊपर आया, but I'll just briefly go through each one of them. ठीक है, this one, अच्छा ये सारे gas jars हैं और gas collection के method हैं. This one is a measuring syringe. That's a good method क्योंकि you can accurately measure the volume of the gas and it's calibrated as well. ठीक है. This one over here is known as you call it the downward delivery. ठीक है, that's the name of this one, and this one is for heavy gases. ठीक है, and heavy gases का मतलब है heavier than air, which means it should be greater than 29. Air is approximately has a mass of 29. So for example, carbon dioxide is 44. So that is when you're going to use that method. So this one is called collecting gases over water, and you pass a gas and the gas bubbles through it through water or whatever the solvent is. ठीक है, not necessarily water, it could be any solvent, and the gas gets collected in this pocket of it gets trapped in this pocket over here. अच्छा, this one is not suitable for soluble gases. ठीक है, soluble gases like ammonia is very soluble, HCl gas is very soluble, so it's not suitable for soluble gases. And the last one is the opposite of the first one, and this one is upward delivery, and this is for light gases, and specifically lighter than air, which have a lower mass than air. So now this one, which method is suitable for collecting a gas which has the properties described? So for example, less dense than air and soluble in water. So would you use apparatus number 1? Hamza, movies
No,
rough.
sir.
ठीक है, you're not, क्योंकि it's the problem is it is less dense. So less dense जो है, that's going to it's just going to escape. It's lighter. So B is denser than air and soluble in water. So would you use option number 2?
Yes.
I said, remember, option number 2 can be used for any gas, whatever the property is. I mean, it's just a gas that's getting trapped over here. So option number 2 can be used for any gas, no matter what the property is, whether it's dense there, lighter than air, or soluble or not soluble. Doesn't really matter. All gases can be collected using a measuring syringe. But just to confirm this, option number 3 is less dense than air and soluble in water. So this one you're not going to use for gases that are soluble in water. So 3 is wrong. And number 4, the last one, denser than air, nahi, that's for lighter than air. Okay, so that's also wrong. So option 2 is the only correct option. Next one, and acidification. After acidification with dilute nitric acid, a colorless solution of X reacts with aqueous silver nitrate to give a white precipitate. So this is for the test for cations and anions. Okay? You have to remember the sheet that I gave you earlier as well, and I'm just going to quickly open it. Just a second. Where is it? Data sheet. Okay, this one. So this one has all the tests that are given plus this over here. So look at the test silver nitrate. What do you test with silver nitrate? So where are anions? So these are anions. Remember, for silver nitrate, Cl -1, Br -1, and I -1, all the tests are with silver nitrate. You acidify with dilute nitric acid, and then you add silver nitrate, and in each case, you get a different precipitate. For the first one, you get a white precipitate, then you get a cream precipitate, then you get a yellow precipitate for I -1. So look at the question carefully, saying that nitric acid and a colorless solution of X reacts to give a white precipitate. So according to the data sheet, a white precipitate is for option number 1, Cl -1. So that is what's going to give a white precipitate. So you've got 2 chlorides. This one also has Cl -1 and this one also has Cl -1. So कौन बताएगा कि which one is the correct option? Like both of them are going to give a white precipitate. So that is true. The other thing he's talking about is that the solution was originally colorless. So is it, huh? अच्छा,
Sodium chloride.
ठीक है, it can't be copper क्योंकि transition metals, they always have colored compounds and colored solutions. So originally you had a colorless solution, so that means it must be NaCl. Or वैसे भी that's normal table salt, it always has a colorless solution. So D is the correct option for this one. Next is about chromatography, and the diagram represents a chromatogram of the colorless acids present in a drink. The chromatogram has been treated with a locating agent. A table of RF values is given over here. So what's RF value? RF value is the distance. For example, for spot number 1, it's the distance traveled by the dye divided by the total distance वो top से लेके starting point तक, ठीक है? The distance traveled by the solvent. So can anyone guess? So you can't really guess over here. I mean, we're going to guess. In the actual paper, you'll have a ruler, and you're going to use this. Approximately, what could be the values for 1 and 2? Like, if I'm just going to make approximations. Okay? For example, this one is 1 centimeter. Okay? If you have a ruler, you can put it next to the screen. It doesn't really matter if it's up to scale. You get the same RF value. So this one is 1 centimeter. This one kind of looks like what? 6 centimeters. So what is on your calculator? What is 1/6? The other one,
0.17.
0 point.
17.
So ठीक है 0.17 and अच्छा the main अच्छा so 0.17 and the other one 2 is also, so I think the first two spots are kind of these two. I mean that's just my guess. We don't have a ruler with us, and this one is kind of, I think it's right in the middle. I mean just have to, if it's right in the middle, it's going to give you 0.5. Like if this is 5 centimeter and this is 10 centimeters, this would come out to be 5/10, which is 0.5. So I think it's going to be two of these, tartaric or citric acid together. And the third one is going to be not malic acid. So this one is wrong. The third one is probably one of these two. So let's have another look. I mean, this one is citric and malic acid. And then you have a I mean, it depends. I mean, you need to have a ruler. Okay. Can anyone do this by putting a ruler next to it and tell me exact values? राफे किया आपने?
Sir, I'm doing it.
ठीक है, just put a ruler. Tell me from the starting point, from the original line. Hamza, just put a ruler next to the screen. Tell me what the value is. I mean, what's the distance over here? This blue one. राफे से first का बता दो. Then we'll. Did anyone do this for the first? Hamza, are you there? Murza, kiye?
Yes, I'm doing it once. So for the first one, it is 0.9.
No, there is no 0.9. What's the distance over here? 1 to this starting point.
This is 0.9.
Achha, the distance is 0.9 centimeters, ठीक है? And what's the distance traveled by the die from the starting point to the end? Hmm? So everyone is going to get a different value. Okay, I mean, the distances would be different for everyone because of the scale.
Say the total distance is 6 from me.
Nee, but your distance would be different from Rafis because your screen is different from Rafis. Okay, so Hamza, फिर दोनों values बताओ. What's the first one and what's this one? The small one and the big one.
So the first is around 1, like 0.9 or 1.
अच्छा ठीक है. And this is around 6.
Yes, sir.
So ठीक है. What's 0.9 divided by 6? 0.16.
So 0.15.
अच्छा फिर से वही issue आ रहा है. अच्छा I mean you have to print it out and then measure it properly with your ruler. ठीक है. But you know how to solve this, right?
Yes.
So I'm just going to move because the thing is the values are very close together. 0.45 and 0.5 are really close together, so you have to be very accurate with the ruler. So you can only do that on a piece of paper. So which gas will diffuse at the fastest rate? How do you figure out which one is the fastest gas? The one that is the light one or the heavy one?
Light one.
As a light one. So argon, I think. I mean, it's probably going to be this one. The fluorine is 19 plus 19. Carbon dioxide is 12 plus 16 plus 16. C3, it's 12 into 3 plus there are 8 hydrogens. And argon, I'm not sure what argon is.
Then it will be D.
What is argon?
Argon is at 40.
Achha, so that makes it fluorine being the lightest gas. ठीक है, 38. Right? हाँ, ठीक है, that's the lightest. As the next one, two particles, K plus 1 and AR, can be written as which statement of these particles is correct? So K plus 1, 39 and 19. Can you tell me it has 19 protons? How many electrons does it have? K plus 1.
20.
It was supposed to be 19 electrons. The protons and electrons are the same, but since it's plus 1, so there's going
18,
to be
sorry.
so there's going to be 18 electrons. And the difference is the number of neutrons. So it's 39 minus 19, so that gives you what, 20? So next is about argon. So that is 40 plus 18, so that's 18 protons, and it's a neutral atom, so it's going to have the same number of electrons. And the difference is going to be 22 neutrons, right? So he's saying first one, AR has more neutrons than K plus 1. So AR, so that's true. For the first one is true. AR has more neutrons than K. ठीक है, is this clear? Hamza clear है? Murza? Moiz, is this clear?
Sir, how does
Yes.
Yes, sir. K have 18 electrons?
Because it's plus 1.
Oh, okay.
ठीक है, that means it lost an electron. Next, that's the next one. A mineral deposit is found to contain small grains made entirely of the element carbon. Which property will definitely be true of the grains of carbon? So, small grains of carbon. How many different types of carbons do you have? Remember, in Balki, we just did this. We did revision for this. कहाँ पे गया? Where's your board? Actually, this one. We did carbon recently, and we talked about the allotropes of carbon. That carbon existed in two forms, not just in two forms. There are other forms as well. There's either diamond where carbon is making 4 bonds, or it's in a sheet-like structure where carbon is making, each of the carbon atoms are making 3 bonds each, and the fourth is conducting electricity. So this is graphite and this is diamond. So you've got these two structures. So he's saying which property will definitely be true of the grains of carbon. So we're not sure whether it's graphite or the grains are diamond. So they will be made of atoms arranged in layers. We're not sure. It could be diamond. It could be tiny pieces of diamonds. So in diamond, the atoms are not arranged in layers. They are all tetrahedrally arranged, all bonded to each other. They'll be soft. Which one is soft? Diamond is very strong. Graphite is the one that's soft because the layers can slide over one another. So that's also not definitely true. I said they will burn to give carbon dioxide. Is that true for both? I mean, whenever carbon is burnt, then carbon dioxide is going to be produced, whether it's diamond, whether it's graphite. So this statement is true for both because both of the forms are carbon. You burn them, you get carbon dioxide. They will conduct electricity. That's not going to be true for both because this one conducts electricity. This one has no free moving electrons. So option C is the correct one. As the next one, you've got calcium fluoride, and you're supposed to figure out the dot and cross diagram of calcium fluoride. First thing, can you tell me whether it's going to be sharing of electrons or whether it's going to be ionic? You've got calcium and you've got fluorine. Calcium is group 2 and fluorine is group 7. Anyone? Ionic or covalent?
Ion.
Okay, so it's going to be ionic because it's a metal plus non-metal reaction. It's in group 2, so that means it has 2 valence electrons, which means it's going to lose 2 electrons. Fluorine is in group 7, so it already has 7 electrons. It's going to gain just 1 electron. So they're going to be 2 fluorines. So it's definitely not the first two. So calcium is the one that's going to lose 2 electrons. It's going to form calcium plus 2. So this one is wrong because it won't be gaining electrons. And it's going to give 1 electron to fluorine over here, -1. So that's the 1 electron coming from calcium. And calcium would lose another electron to another fluorine. So that one is also -1. So C is the correct option. TK, is this clear? Hamza, Murza, Rafe, Muiz, clear?
Yes, sir.
Yes.
So next, how many shared pair of electrons are there in one carbon dioxide molecule? So how many shared pair of electrons are there in carbon dioxide molecule? How did we learn how to make carbon now carbon dioxide is a covalent molecule because both of them are non-metals. Carbon, remember, is in group, we also drew the structure somewhere before this. Actually, we didn't. So I told you that anything that's in group 4, that's going to make 4 bonds. Oxygen is in group 6, so it's going to make 2 bonds. So we're going to follow the same thing. Carbon is going to make 4 bonds, 2 with one of the oxygens, because oxygen is only going to make 2 bonds, 2 with the other oxygen atom. So in total, how many electrons are being shared? A double bond over here, a double bond over here. So that means 4 electrons being shared over here and 4 electrons being shared over here. And that would just give you 8. TK, is this clear?
There isn't he asking for a shared pair of electrons?
So acha, TK. So that would mean not 8 actually. Because he's talking about pairs. So 2 pairs over here, which is 4 electrons, and 2 pairs over here. So that would give you 4. TK? Rafe, TK. Hamza, is this clear?
Yes, sir.
As the next one is 2 statements about metals are given. Metals contain a lattice of negative ions and a sea of electrons. We did metals, I think, after this. So we talked about metals being a lattice of positive ions, a regular arrangement of positive ions in a sea of free moving electrons. So that is exactly what it is. So it's a lattice. So the first statement is incorrect. It's not negative ions, it's positive ions. So the first one is incorrect. The electrical conductivity of metals is related to the mobility of electrons in the structure, which is true because the reason why metals conduct electricity is because the electrons are mobile, are free moving. Okay? So that's the reason why they conduct electricity. So the second statement is correct. So statement 2 is correct and statement 1 is absolutely incorrect. Achha, then you're given Achha, now this is the thing that we're doing. Powdered calcium carbonate reacts with hydrochloric acid to produce calcium chloride water, and you're supposed to write the Ionic equation. So how did we learn to write the Ionic? This was what we were up to. I think we had started salt preparation. So I'm just going to quickly write the Ionic equation of calcium carbonate, which is a solid, is insoluble. You need to remember the solubility table. All carbonates are insoluble except for those that are in group 1, and he's reacting with hydrochloric acid, HCl, so all acids are aqueous. They are by default soluble. And calcium chloride is formed. Calcium is 2 plus, Cl is minus 1, so it's going to be CaCl2. And all chlorides are soluble except for silver and lead. So this is also aqueous, and you got water and you got carbon dioxide. So carbonate plus acid produces salt, water, and carbon dioxide gas. Now the thing is, how do you write Ionic equations that this is not balanced? First let's balance it as well to HCl aqueous, right? Now what we learned about aqueous things was that they mix with water and the ions, they kind of dissociate. So calcium carbonate ions would still be together because they're not dissociating, so they're still solid. The acid, the ions would scatter in water, so it's going to be 2H plus 1 and 2Cl. And that's going to be aqueous. Calcium chloride is also aqueous, so the ions would dissociate. Plus, there's going to be water and there's going to be carbon dioxide gas. So you have this going on. Which one is the spectator, Ryan?
Cl.
As a Cl is not doing anything, so you just remove Cl. It's completely unchanged in the reaction. Didn't do anything. And the rest of your equation, you just rub off Cl minus 1. That's your Ionic equation. Get rid of Cl minus 1. So the rest of your equation is your Ionic equation. So it's calcium carbonate plus 2H plus 1, forming calcium 2 plus H2O plus CO2. And that's your answer. So it's going to be the last one, which is D. Okay. I said then you have moles. So although we haven't, I mean, you've already studied this, but what mass of carbon contains the same number of atoms as 16 grams of sulfur? So first thing is, how many moles of atoms does sulfur contain? How do you find moles? Moles is mass divided by the AR. Mass is 16 grams and the AR of sulfur is 32. Now you do that, that gives you 0.5 moles. So you get 0.5 moles. So basically we're looking for 0.5 moles. I mean 0.5 moles of sulfur. So he's saying what mass of carbon would contain the same number. So we're looking for 0.5 moles of carbon. So I'm going to use the formula again, but this time for carbon. So I have the moles, 0.5 moles of carbon. What is moles? Mass divided by the AR or MR. And this is for carbon now. I've got 0.5 moles of carbon. Carbon is 12. So if I multiply 12 with 0.5, I get 6 grams. So B is the answer. So I'm just going to repeat the question. That, I mean, they were supposed to have the same number of moles. 16 grams divided by the AR of sulfur would give you 0.5 moles. So carbon moles should be exactly the same as well because he's saying the same number of atoms. So the same amount of or quantity of atoms, that means 0.5 moles of carbon. Moles is mass divided by AR. Carbon's AR is 12. 12 goes there and you get 6 grams. TK, is this clear? Hamza, is this clear? Murtaza?
Yes, sir.
Moiz?
Yes, sir.
That's the next one. This one is 3 dm cube of sulfur dioxide is reacted with 2 dm cube of oxygen. Assuming the reaction is to completion, all gases are at room temperature and pressure, what volume of sulfur dioxide trioxide is formed? So now remember, for gases, I told you that mole ratio and volume ratio is exactly the same. What's the mole ratio? The equation states that two molecules react with one molecule, right? So it's 2:1. Now, can anyone tell me, according to this ratio, 3 would react with how much? Would it react with 2 or not? Like 2 reacts with 1. That means SO2 and O2, the ratio is 2:1. So according to this ratio, I mean, you can do ratios quickly. 2 reacts with 1. So what would 3 dm cube react with? That's going to be x. You crisscross and multiply. And the answer that you're going to get for x is going to be 1.5 dm cube. Is this clear?
Can you explain again?
Hmm?
Well, I didn't understand this part. How did we get 1.5?
Actually, वो मैं इधर एक सेकेंड इधर मैं कर दूं कि there's a thing in moles about gases, and that is कि if you have a reaction going on, and let's assume that all of them are gases, right? So the equation is suggesting that two molecules of H2 react with one molecule of O2 to produce two molecules of H2O, right? And let's assume all of them are gases. The rule is that the mole ratio in which the reactants and the products are reacting and getting produced, and the volume ratio is exactly the same. So if you had, let's say I had 500 dm cube of hydrogen gas. So can you tell me, according to the ratio 2:1, what would be the amount of oxygen that would react with it? ठीक है, according to the ratio, it's going to be 250 dm cube that's going to react with it. I mean, you don't need formulas for this. TK, if you're comparing gases, the mole ratio and volume ratio are going to be exactly the same. And 2H2 produce 2H2O. So that means 500 dm cube is going to produce the same amount. TK, Murza, Rafe, bakiyon ko, is this clear? Moiz, is this clear?
Yes.
Yes, sir.
But remember, this is only true for gases. Whenever you have gases, the equation में जो भी mole ratio दिया हुआ है ना, that's the ratio in which the volume of the gases would react. Now, the thing over here is, in this question, it was 2SO2 reacting with O2, and it was producing 2 molecules of SO3, right? All of them are gases. So according to this ratio, if I had 3 dm cube of SO2, can you tell me, according to this ratio, how much? I mean, 2 reacts with 1. So 3 dm cube is going to react with how much oxygen?
1.5.
Okay, so it's going to be 1.5 dm cube, and it's 2:2. I mean, there's 2 over here and there's 2 over here, so that means 3 dm cube would produce exactly 3 dm cube. Is this clear?
Yes, sir.
Achha, so in this question, this was a limiting and excess question, because if you look at the question, he told us that 3 dm cube was reacting with 2 dm cube, which is not going to be true, because according to the ratio 2:1, 3 would only react with 1.5. That means the oxygen that was added was in excess. It was more than the required amount. You don't need 2 dm cube. You just need 1.5 dm cube. And so according to the ratio, 3 would react with 1.5 to produce, since it's 2:2, the amount of SO3 produced would also be 3 dm cube. Okay, because it's 2SO2 would produce 2SO3. So the thing was that when you were doing moles, the number that's in excess, that's never used. I mean, you're never going to use 2 dm cube in the ratios, because 2 dm cube is not the amount that is actually taking part in the reaction. The actual true value is 1.5 dm cube. because 2 DMQ was added in excess. It was never going to react. 3 would only react with 1.5 according to the ratio. Is this point clear?
Yes, sir.
बाकियों clear? Murtaza, Hamza?
जी sir.
Yes, sir.
ठीक है. अच्छा, क्योंकि if you had used 2 DMQ, ठीक है, just assuming, let's because you had to figure out which one was in excess. So for example, if you had made the mistake, okay, you saw okay there was 2 DMQ of oxygen that was taking part in the reaction, right? And you had no idea that was in excess. So according to the ratio, 1 produces 2, right? So you would have thought that according to the ratio, 4 DMQ of SO3 must have been produced, right? Because you're assuming that all of the 2 DMQ is taking part of the reaction, which it isn't. Because we figured out that 3 DMQ of sulfur dioxide only reacts with 1.5, not with 2. So which is why it's very important to get rid of the excess reactant. You never use the number moles of the reactant that's in excess. Is this point clear?
Yes, sir.
ठीक है. I'm just going to make this point even clearer. For example, if I have a reaction, there's NaOH plus HCl and it's reacting with it's producing NaCl plus H2, and all of them are reacting in 1:1. Now, somebody says that he's adding 0.5 moles of NaOH into 1.5 moles of HCl, and he's asking what amount of NaCl would be produced. Now, all of it is 1:1. Now, if you take 1.5 moles of HCl, so according to the ratio, 1 HCl produces 1 NaCl, you're going to think that 1.5 NaCl would be produced, right? Because you're assuming that all of the 1.5 moles of HCl would have reacted, right? But that would be incorrect, because if you look at the two reactants, which one is in excess? कौन सा excess में?
Anyway,
नहीं, excess में it's 1:1, right? तो मुझे बताओ कि 0.5 will react with how much according to the ratio? 0.5 will react with 0.5 moles, right?
yes.
तो इसका मतलब है you don't need 1.5. 1.5 is too much. I mean, 1.5 is not going to take part in the reaction, because 0.5 moles, according to the ratio, 0.5 moles would only react with 0.5 moles. 1:1. ठीक है, the equation is saying कि NaOH के जितने भी molecules होंगे ना, HCl के उतने ही molecules होंगे. So 0.5 will react with 0.5. So which is why this number is completely irrelevant, because you added too much and it's not going to take part in the reaction. Clear है, Hamza? Moise, is this clear?
Yes, sir.
And therefore, since NaCl is also in 1:1, so if 0.5 is reacting with 0.5, so it's going to produce 0.5 moles. So it's extremely important that you get rid of the excess moles, and you're not going to use the excess moles in your equation. It gets kind of more trickier if the ratio is very different. For example, here's another reaction where N2 and H2 are reacting, and you're being asked to figure out the amount of NH3 that's going to be produced. Now the question is, you're given 1.5 moles of N2 and you're given 6 moles. Okay, let's do it the other way around. Let's say you're given 2 moles of N2 and you're given 4.5 moles of H2. Which one is in excess? Which one has been added more than the required amount? And the ratio is very different. It's 3:1. So can you tell me, will N2 be able to react with all the H2? According to the ratio, 2 moles would react with how much? क्या होगा? 1:3. So 2 is going to react with So 2 needs 6 moles, right? 6 moles. But you don't have 6 moles. So that means 2 moles are not going to take part in the reaction. Not all of them. Because there's not enough H2 to react with it. Hamza, is this clear?
Yes, sir.
And you can do the reverse ratio, like 3 reacts with 1, so 4.5 will react with 1.5. That means only 1.5 moles of N2 would, I mean, it's 3:1, right? So you get rid of the excess number. This number is not going to react or take part in the reaction. So 3:1, so 4.5 would react with 1.5. And if it reacts with 1.5, that means this one was the one that's in excess. So when you're trying to find NH3 moles, never use this 2 moles. Okay, you're going to get the wrong answer, because if you had used 2 moles, the 1:2 would give you 4 moles over here, which is going to be incorrect because 2 moles are not taking part in the reaction. 1.5 are taking part in the reaction. So 1:2, that gives you 1.5 are going to produce double that. It's going to be 3 moles. Okay, is this clear?
Yes, sir.
I said, then you have a sample of magnesium hydroxide is made by adding an excess of aqueous sodium hydroxide to aqueous solution containing 12 grams of magnesium sulfate, and the mass of magnesium hydroxide formed is 0.2. What is the percentage yield of? So this one, first thing, you should be good at making an equation. I said, now for this, remember he's saying he's making magnesium hydroxide by adding sodium hydroxide to magnesium sulfate. Now this, we did methods of preparation. This is the third method of preparation which we didn't revise. So I'm going to just do that right now. Or did we revise? I don't think we revised. We did titration. We didn't do this one. Now this third one is going to be known as, the third one would be known as ionic precipitation. Precipitation. Now, what happens in this method? In this method, what happens is you mix any two soluble acids or bases or salts. Basically, you mix anything that contains ions, positive and negative. Like acids have H plus 1 and some negative ion, bases have O minus 2 or OH minus 1. So anything that contains ion, and the condition is that they must be soluble. This is a method for producing insoluble salts. So for example, in this question, he's saying that he's mixing, I think, NaOH with what? With magnesium sulfate, I think. One of them is a base, provided they shouldn't react. One of them is a base, the other one is a salt, so they're not going to take part in the reaction. There is no base plus salt reaction. But both of them are soluble. Na is group 1. Anything that contains group 1 that's soluble, and anything that all sulfates are soluble except for some of the sulfates. I mean, I can go back and show you. This was the solubility table. So about sulfates, pretty much all of them are soluble except for 3, 4. So that's for sulfates. Now, what happens in ionic precipitation? You mix two substances, and whenever something is aqueous, they dissociate into ions. So if you add NaOH aqueous, the sodium ions and the OH ions, they would dissociate. If you add magnesium sulfate to the same solution, and magnesium sulfate is soluble, so the Mg ions and the SO4 minus 2 ions would get scattered in water, and they would all go their different ways, right? So your solution would eventually be a mixture of these ions, and these ions would be randomly combining together. Which two ions can combine to form something that's insoluble? I mean, you've got Na can combine with SO4 and that would form sodium sulfate, but any group 1 compound that's soluble. Hydroxides are insoluble, so if Mg combines with OH, a precipitate of MgOH2 is formed. Mg is 2 plus OH is minus 1, so it's MgOH2. And this thing is insoluble. So the ions would join up and they would start forming a precipitate of MgOH twice. Okay, because MgOH2 is insoluble. Is that clear? Yes or no? Is this clear? Plus what's going to be left in the solution would be sodium. Hamza, is this clear, Rafe? Murza?
Yes.
Plus your sodium sulfate would remain part of the solution. So ionic precipitation only happens if the ions kind of join together to form something that's insoluble, which is true in this case. So this is the equation that he's talking about, and the Mole's question was about this particular equation. You can balance this equation. There's two Na, so you can balance the Na, and I think the OH are also balanced, and pretty much everything looks balanced, I think. Okay, so this was the equation, and the Mole's question was about this particular equation. So we're going to try and do this. As a weekends, maybe we'll do another past paper class. I'm going to try and complete this past paper. Just make sure we remember what this past paper is. Just gonna एक second. I'm going to post this in the group. किधर गया आपका group? अच्छा, this one. So we're going to continue with this paper, ठीक है? Or tomorrow, are you available anytime tomorrow?